All right, advent of code, day 17. Here we go. As your flight slowly drifts through the sky, the elves at the Mythical Information Bureau at the North Pole contact you. They'd like some help debugging a malfunctioning experimental energy source aboard one of their secret super satellites. Based on cutting-edge technology, it's having problems. Your pocket dimension contains an infinite three-dimensional grid. At integer three-dimensional coordinates XYZ, there exists a single cube which is either active or inactive. In the initial state of the pocket dimension, almost all cubes start inactive. The only exception to this is this small flat region of cubes, your puzzle input. The cubes in this region start in the specified active or inactive state. Energy source proceeds to boot up by executing 6 cycles. Okay. Each cube only ever considers its neighbors, any of the other 26 cubes where any of their coordinates differ by at most 1. Okay. During the cycle, all cube. Okay, this is just equals stirs dot each do stir with index I or y each with index to cars x if okay. How many cubes are active state after the 6th cycle? Okay. Min x equals whatever, I'll update that after. If ch equals a £sign is active, yeah. Map x, y, 0 equals true. X range equals 0, 0, y range equals 0, 0, z range equals 0, 0, def update range, r val, min r0 val, r0 val dot min, r1 val dot max. XR equals update range x range x. And then 6 dot times do x r0 x r1 dot each do x and new map equals -1 dot each do dx next if dx equals 0 and dy equals 0 and dz equals 0, if new map if map x num neighbors equals 0 If map x plus dx, y plus dy, z plus dz, num neighbors plus equals 1. If map x, y, z, else if it's active, if num neighbors equals 2 or num neighbors equals 3, new state equals false, new state equals true, false, else, and if it's inactive but exactly 3 of its neighbors are active, Q becomes active. New map x, y, z equals new state. If new state six cycles, and then puts part 1 map dot values dot count itself, true, false, 3 dot count false itself. Okay. Each 35. What did I do wrong? Puts map.inspect. Okay. Puts XR. Puts X, Y, Z. Puts that. What? Oh. Minus. What? What the heck? There we go. '82 leaderboard. Yes. Part 2. For some reason, your simulated results don't match the experimental results. Apparently, the pocket dimension actually has 4 spatial dimensions. Each cube only ever considers its neighbors, any of the 80 other cubes. Okay. After the 6th cycle. Okay. W range. W and W equals 0. W plus dW. And W, 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 and 0 puts Whew. I think I just gotta hold that. Yes! Leaderboard. Both parts. And it's my birthday tomorrow. That's what I'm talking about. What's up, Zerankowitz? Are you already done? Did you do it already? Oh, what the heck? How are you so fast? Ugh. 82. Dang, where were you? 33rd? And 26th? Dang. Congratulations. All right. Let's go back to the problem. Read through it again. Pretty easy today. Oh, wow. It's literally called Conway cubes. Okay. Our second game of life implementation. Man, where did I lose time? Oh, yeah. I lost a lot of time because I had map equals this instead of map equals new map. And I think I probably spent like a minute, at least a minute, printing stuff out, trying to figure that out. Anyway, this is literally just game of life. Yeah, are the rules the same? I think the inactive rules are slightly different. But it's basically, I'll just read it through. As your flight slowly drifts through the sky, the elves at the Mythical Information Bureau at the North Pole contact you. They'd like some help debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites. The experimental energy source is based on cutting-edge technology, a set of Conway cubes contained in a pocket dimension. When you hear it's having problems, you can't help but agree to take a look. The pocket dimension contains an infinite three-dimensional... Wait, what? As I'm reading this, I'm just reading the words and not taking in any of the content. But now I'm realizing what it's talking about. Elves at the Mythical Information Bureau. There's a malfunctioning experimental energy source with Conway cubes. This pocket dimension contains an infinite three-dimensional grid. At every integer coordinate, there's a cube that's either active or inactive. They all start inactive, and that's your puzzle state, which is just in the z equals 0 plane. And then it boots up by going through 6 cycles, and at each iteration, it considers its neighbors. If it's active and there are 2, 3 neighbors, then it stays active, otherwise it dies. If it's inactive, if there are exactly 3 neighbors, it becomes active. And so the key thing here is just to, we keep track of which of the ranges that we're considering, which start at, I have this update range thing, which basically says like, oh, if this was our range before, like if before we were considering x's, because it'll grow outwards, before if we were saying x is between like 0 and 3, and then we have a new x at 3, then we need to consider x equals 4 the next time. And so we basically do like the max, new max will be the end of the range and the value plus 1, the max of those. So we have this update range, we initialize our map, and then we loop through over x, y, z. Basically, part 2 is literally just, it's 3 dimensions, or it's 4 dimensions. So I just added, I loop through over all the coordinates in the ranges, over all the dimensions, or over all the deltas, skip if we're considering the same thing. If that value, we increment the number of neighbors, and then we just have, this should be better initialized to nil. If there are if it's alive and there are 2 or 3 neighbors, we make it true, otherwise we make it false. Alive, otherwise we make it dead. If it's dead and it has exactly 3 neighbors, then we make it alive. And then we update the new map, and then we update our ranges for next time. And then critically at the end, we have to update our whole map, which I lost like minutes on. And then we just count how many values are equal to true. So 2.times do part and then basically if part equal next if part equals 1 and dw not equal 0. Or what if I do this? W range equals part equals 1, 0, 0, otherwise that should work. Oh, original map equals map. Map equals original map. There we go. What's going on? Why is this taking so long? Whoa. Man, I'm pumped. I did it. Leaderboard. That's what it's all about. Wow, this is taking so much longer in 4 dimensions. Wait, part 0 was still 2280, and then part 1 was 388. Oh, that's why. 1, 2. There we go. There we go. Boom. Oh, that's still cached. December 17th.